Hello everyone. Today I am going to explain a very interesting machine learning project called real facial recognition using PCA and EigenFaces. This project is built to recognize human faces using a mathematical technique called principal component analysis or PCA. So let's move towards its introduction, that what is this project is whole about. So the main goal of this project is very simple. Just like you recognize your friends by looking at their eyes, nose, or smile, a computer can also learn to recognize faces, but it does it using numbers and math instead of emotions. We give the computer some training images of people, and then we ask it to identify new unseen images of the same people. That's the whole idea about my whole project. For this project, we use a famous dataset called Olivetti Faces Dataset. It contains 400 images of 40 different people. Each person has 10 images taken at different times with different lighting and different facial expressions. All images are black and white, and each image is 64 cross 64 pixels in size. In our project, we don't use all 40 people. Instead, we select only 10 people for simplicity. So 10 people cross 10 images, each is equals to 100 total images that we work with. Now, here comes the most important concept that I used in this project is PCA. PCA basically stands for Principal Component Analysis. It is dimensional reduction technique, but what does that mean in simple words? Imagine each face image has 64 cross 64 is equals to 4090 pixels. That means every face is a point in 4096 dimensional space, which is huge and complicated. PCA helps us compress this data. It finds the most important features in all the faces, like the shape of our eyes, nose, and face structure, and ignores unnecessary details like background or noise. These important features are called principal components, and when we apply PCA, especially to faces, these components are called eigenfaces. Now, what are eigenfaces? What are eigenfaces? The word eigen comes from German and means own or characteristic. So eigenfaces are basically characteristic face templates. Instead of storing a whole face as 1,000 of pixels, we represent each face as a combination of these eigenfaces. Think of it like mixing primary colors red, green, blue to create any color. Similarly, by mixing eigenfaces, we can recreate any face in our data set. In our project, we use 10 eigenfaces to represent all faces. Now I'll explain the main dashboard. It is like a control panel where we can adjust settings and see the result. First, we move towards the data set. Here, the data set is real Olivetti, which confirms you are using the real world Olivetti data set. Person selection. We have an option also called number of persons to use. This let us to choose how many people we want in our system to recognize. We have selected 10 persons. So our system will learn to recognize exactly 10 different individuals. Dataset size. The dataset size shows 100 images because 10% into 10 images each is equals to 100 total images. Eigenfaces count. The eigenfaces field shows 10, meaning the system has generated 10 eigenfaces templates from training data. Now, accuracy. Accuracy is displayed as 70%. This means out of all these images, the system correctly recognized 70% out of 100 images. That's a pretty good result for a basic system. Test site slider. We have a test size slider that controls how many images we keep aside for testing. For example, if we set it 20%, then 20 images are used for testing and 80 for training. Number of eigen slider. We have a slider to choose how many eigen faces we want to use. More eigen faces equals to more detailed but slower. So fewer eigen faces equal to faster but less accurate. We have set it to 10. K-nearest neighbors. For classification, we use an algorithm called K-nearest neighbors. When a new face comes, the system finds the most similar faces from the training data. Then it looks at their labels and picks the most common one. It is like asking 10 of your friends, what does this new person look like? And going with the majority answer. Finally, there is a train and test button. The system trains itself on the training images, then it tests itself on the test images, and finally it shows the accuracy. Now let's move towards the mean face. The first visualization is called mean face. This is simply the average of all the training faces. The system takes every pixel from every face and calculates the average value. The result is a blurry, ghost-like face that represents the common face of all the people. It's like the average person in our data set. Top eigenfaces section. The second visualization shows the top eigenfaces. These are the most important templates that captures the maximum variation among faces. The first eigenface captures the biggest difference like lighting. The second captures the next biggest difference like face shape and so on. These eigenfaces act as the building blocks for all the faces. Section number 7 that includes face recognition. The third and final visualization is called facial recognition. Here we take an original face from the data set and try to reconstruct it using only the 10 eigenfaces we have. The top image is the original face. The bottom image is the reconstructed face. If the bottom image looks very similar to the top one, it means our eigenfaces have captured the essential features correctly. If it looks blurry or different, it means we need more eigenfaces for better accuracy. The reconstruction shows us how much information we lost during compression and helps us decide the right number of eigenfaces. This is all about my whole project. Thank you guys. Here, by increasing the number of eigenfaces, our accuracy is 100% and mean face look like this. And face recognition faces changes to this, which means that our mean face is shows recognition with the facial construction, face reconstruction phases that shown here. Thank you guys. Keep learning and keep exploring.